What if the biggest mystery in the universe could be hiding inside the darkest objects we know? For decades, scientists have been chasing the ghostly substance called dark matter, the invisible glue that holds galaxies together. But what if dark matter isn't exotic particles or hidden dimensions? What if it's something far more familiar? Black holes. Specifically, primordial black holes that may have formed right after the Big Bang. Stick around, because today we're unpacking one of the most mind-bending theories in modern cosmology. Could black holes themselves be the missing dark matter? Dark matter makes up about 85% of the universe's mass, yet we've never seen it directly. It doesn't emit light, it doesn't absorb it, and it barely interacts with normal matter, except through gravity. For years, physicists have proposed exotic candidates: WIMPs, weakly interacting massive particles; axions, hypothetical ultralight particles; or even stranger ideas like sterile neutrinos. But here's the problem. Despite decades of experiments, we've found nothing. Particle colliders, underground detectors, space telescopes, still no smoking gun. That's where the idea of primordial black holes enters the scene. Unlike the black holes we know, formed when stars die, primordial black holes, or PBHs, are thought to have formed in the first second after the Big Bang. Imagine the newborn universe: chaotic, dense, uneven. Some regions were slightly denser than others. If those fluctuations were extreme enough, gravity could have crushed them into black holes instantly. These PBHs wouldn't need stars, galaxies, or anything else, just raw gravity in the early chaos. Why do they make good dark matter candidates? Because they're non-baryonic, not made of normal protons and neutrons. They're stable if heavy enough. They move slowly relative to light speed, and they interact mainly through gravity. In other words, they check nearly every box for dark matter. Now, before you go shouting "mystery solved," there's a catch. Lots of them. Scientists have tested this idea in clever ways. One, gravitational microlensing. If a PBH passed in front of a distant star, it would bend light like a cosmic magnifying glass. Surveys like Ogle and Macho have looked for these events, and the results rule out large populations of PBHs in certain mass ranges. Number 2, Hawking radiation. Stephen Hawking predicted tiny black holes should evaporate by releasing energy. If PBHs were too small, we'd see bursts of gamma rays today. But we don't, so those lightweights are out. 3, Cosmic microwave background, CMB. PBHs could have distorted the leftover radiation from the Big Bang. No major distortions have been found, meaning PBHs can't dominate in certain ranges. 4, Gravitational waves, LIGO-Virgo. Merging black holes detected since 2015 sparked renewed interest in PBHs. Could some of those mergers have been primordial? Possibly. But current data suggest PBHs can only make up a fraction of dark matter in that stellar mass range. So, are PBHs dead as a theory? Not quite. Despite all the constraints, there's still a sweet spot left. Asteroid to moon mass black holes, around 10 to 10 squares right grams, remain largely unconstrained. These black holes would be too small to detect with current technology, yet heavy enough to avoid evaporation. Some scientists even suggest a mixed model. Maybe dark matter is partly PBHs and partly exotic particles, like axions. And here's the kicker. If even a fraction of dark matter is PBHs, it could solve two mysteries at once: the origin of certain black holes and the true identity of dark matter. Here's the irony. Einstein's equations predicted black holes, but he personally doubted they could exist in reality. Fast forward a century. Not only do they exist, but they might explain the largest missing piece of his cosmological puzzle. This PBH idea also highlights how science works. First, we imagine new particles like WIMPs. When experiments fail, we return to old ideas with new twists. And sometimes the simplest explanation, that gravity itself made the missing matter, comes back around. But here's the deeper question. What does it say about the universe if the most mysterious matter is simply more black holes? It would mean the cosmos is stranger, but maybe also simpler than we thought. So what do you think? Are primordial black holes the smoking gun for dark matter, or are we chasing another cosmic mirage? Drop your thoughts below. Could black holes explain everything? Or do you think exotic particles like WIMPs still hold the key? I'll feature the most interesting answers in a future video. If you enjoyed this dive into the cosmic frontier, smash that like button so the algorithm knows. Share this video with a fellow space nerd, and subscribe for more deep dives into the strangest mysteries of the universe. Stay curious, stay questioning, and until next time, keep looking up.